So to find out number of radial nodes, we have a formula called n minus L minus 1. What is the formula to find out number of radial nodes? N minus L minus 1. So 4f. N is 4. What is the L value for f? What is the L value for f? Very good. So L is equal to 0, 1, 2, 3 are indicated with SPDF. So the L value for f is 3. So we are asking number of radial nodes for 4f orbital. So the n value is 4, the L value is 3. So the answer is 0. So they will give option 1, 0, option 2, 2, 3, 4, like that they will give. So how can you recall it? If you discuss with your friend many times periodically, because don't think that if you discuss with your friend will learn and he will become doctor. No, I don't want to see him as a doctor or her as a doctor. So don't be that mindset. Discussion will keep the things in active memory for a long time. Instead of just reading by yourself, sometime after your study hour or during dinner or at the time of sleep, every day you discuss 10, 20 questions, cross-check with your friends. You ask 10 zoology questions to him. So he will ask you 10 botany questions. Somebody will ask some physics questions. Like that, a thorough mutual discussion. Within 6 months, your energy levels will be very high. You will be potentially feel that, yes, I am a potential competitor for NEET 2025. Okay, today what shall I do? I will check some of the basic principles or basic information in the first 3 chapters of your 11th class chemistry. One is some basic concepts of chemistry, that is the first chapter. Second chapter is the atomic structure. Third chapter is classification of elements and periodicity in properties. 3 chapters randomly. I will check so many areas and see how you are able to recall the things or how you missed many fundamentals, like that. Suppose in atoms and mole concept, that is the first chapter. Suppose if I ask you a question like this, the number of moles in 90 grams of water, because everybody is having a water bottle, I thought, okay, let us ask a question on water. So 90 grams water is given. Very good. So how many moles? Now actually what is a mole? Is the mole present on my left hand? And no sir, a mole is present on the right cheek. Is that mole or is this another mole? This is another mole. Spelling may be same. Actually, when your mother cooks food, she won't count, my daughter will eat this many grains. This many rice grains my younger daughter will eat. This many grains my elder son will eat. Rather, she will use a cup or glass. She measure with that. She know that cup or glass, whatever the measuring device she is using. She know how many people can eat with that. Even she want to prepare other items also, she will use the same device. For her is a standard. Whatever the food she want to prepare, suppose she want to prepare upma, suji, with suji. Suji also she will measure with the same device. Rice also she will measure with the same device. She want to prepare tur dal. She will also measure the same device. So for your mother, there is a kitchen device, a measuring cup, and she measures with the same whatever the item she wanted to prepare. In chemistry also, we have a measuring device called mole. If you measure 1 mole of any substance, it contains Avogadro number of structural units. So mole is a mass of substance which contain Avogadro's number of structural units. Avogadro number is Na. You can say mole contain this number of structural units, which is called Avogadros. So mole is the mass of the substance which contain Avogadro's number of structural units. So what are these structural units? Suppose I measured 1 mole of helium. Helium is inert gas. It does not contain molecules. Okay, I will take. Helium is an inert gas, monoatomic. So, red, black I will use. Shall I use even bigger font? Okay. Now I am going to elaborate this word structural units. So what are these structural units? It can be atoms, it can be molecules, or it can be formula units. So when shall we use the word atoms for mole. We use the word atoms for mole if the given substance is in atomic state. If the given substance is in atomic state, yes, it is a too lengthy room. Okay. So atoms, the word atoms you can use for mole if the given substance is in atomic state. If the given substance is in atomic state. Which substances are in atomic state? Which substances are in atomic state? Has anyone, what kind of substances exist in atomic state? The answer is all inert gases. Helium, neon, argon, krypton, xenon, radon. All inert gases are in atomic state. What else? All metals. All metals are also in atomic state. Suppose if I use the word 1 mole of aluminium, what does it mean? Avogadro number of atoms of aluminium. If I use the word 1 mole of gold, what does it mean? Avogadro number of gold atoms. Or 1 mole of silver, what does it mean? Avogadro's number of silver atoms. So mole is always equal to a particular number. What is that particular number called? Avogadro's number. So mole always contain Avogadro's number of structural units. The structural units can be atoms, the structural units can be atoms or molecules. What is the third one? Formula units. Which we represent as Na. It is also equal to gram molecular weight, which we call GMW, which is also equal to gram atomic weight, which is also equal to gram formula weight. So mole is a the term which you can use in different contexts. Now as I have asked you, what are the number of moles in 90 grams of water? Few students immediately answered 5 moles. Very good. But remaining students still puzzled how to solve it. So actually molecular weight of water is equal to 18. It has no units. Gram molecular weight If I add a prefix called gram, gram molecular weight of water is equal to 18 grams. When I use the word gram, here also the word gram comes. So what is the gram molecular weight of water? 18 grams. Gram molecular weight is equal to 1 mole. So 1 mole water or 18 grams of water is equal to 1 mole. 90 grams of water, I asked you, equal to how many moles? It is 90 by 18. That is equal to 5 moles. From this, we derive a formula which is a number of moles. N is equal to given weight by gram molecular weight. What is N here? Number of moles. From this formula, what we can say? This problem we solved just now. Molecular weight of water is 18. Gram molecular weight is 18 grams. Gram molecular weight is always equal to mole. So 18 grams of water is equal to 1 mole. We asked to find out number of moles in 90 grams. You got 5 moles. The numerator is given weight, denominator is gram molecular weight. That's how we have derived a simple formula. Number of moles is equal to given weight by gram molecular weight. Now next, what is molecular weight? Then what is atomic weight? Sit down, sit down. Okay, if we add sum of the atomic weights, it is molecular weight. Our answer is correct only. In H2O, there are 2 H atoms, 2 into 1 plus 1 oxygen atom, 16. So total 2 plus 16, 18 is the molecular weight of water. But how do you define molecular weight? How do you define atomic weight? In the class of these doctors, around 48 students, I don't know what is the actual weight of each individual student. Even if I ask, student become very angry. Why are you asking my weight? It is secret. You should not ask. So I will do a different way of expressing your weights. I have chosen, what is your name? Spelling? P-Y-R-M-A-N. Per month. Okay. So in this class, I chose per month as a reference student and I measured his mass. I don't have conventional weights like kgs or pounds. I measured his mass with some bricks. Let us say Parman is weighing 10 bricks. So I wrote a sentence. Mass of Parman is 10 bricks. Next, immediately I weighed the immediate next person to him. What is your name? Spelling. THA? Tarnak. Trang. Okay. So Trang, we weighed Trang, and I found that he is thrice heavier than Parman. So Parman's mass is 10 bricks. Next one is weighing 3 times heavier than Parman. His mass is 30 bricks. So by taking one student as standard, I can express all of your weights in terms of bricks. They are not your real masses. But with reference to Parman, they are true. Because Parman is weighing 10 bricks. The other student is thrice heavier, 30 bricks. Let us say another student is weighing only twice heavier, 20 bricks. Let us say another student is weighing only half, 5 bricks. Like that, by taking one student as standard, I can express all of your masses. They are true with reference to that particular student. Similarly, for atomic masses, molecular masses, atom you can't see it, you can't pick it and keep in a balance and put some weights and measure atomic weight. Oh, this is the atomic weight. Or you can't pick up a water molecule from your water bottle. No sir, my God has given me great vision. I can see the molecule. Okay, you can pick the molecule and put in a balance and put some weights. Which weights? Molecule is also so small. You can't put some conventional weights. So atoms and molecules can't be directly weighed. Correct? Because they are too small. Even if you weigh them, their masses are extremely small. They are in the order of 10 power minus 24 grams. If atoms or molecules are directly weighed, what will be their masses order? They are in the order of 10 power minus 24 grams, which is a very, very small value, practically of no use. That's why for expressing atomic weights, molecular weights, like we have chosen Parman as reference student, in scientific world also, the IUPAC, International Union of Pure and Applied Chemistry, they have chosen 1/12th mass of carbon 12 isotope as standard. So what is the reference element for expressing atomic weights and molecular weights? 1/12th mass of carbon 12 isotope. As a standard to express the atomic weights or molecular weights. This is from 1963 onwards. We are using this standard. Earlier, before 1/12th mass of C12, the earlier standards were 1/16th mass of oxygen 16. Even the earliest standard is 1 unit of hydrogen as standard. Then immediately the student can ask a doubt. Why the earlier standards like hydrogen atomic mass taken as 1 unit, like we have taken his mass as 10 bricks as standard. With that 10 bricks mass, we compared other students' masses also we got. This comparative masses by taking one reference is called relative atomic masses or relative molecular masses. So whatever these so-called atomic weights which we are using nowadays are so-called molecular weights are what? Relative atomic masses, RAM, or relative molecular masses, RMM. So what are the atomic weights and molecular weights nowadays you are using in solving the problems? Just now to solve the number of moles in 90 grams of water, I took molecular weight of water as 18. What is this 18? Means 1 molecule of water is 18 times heavier than 1/12th mass of C12 isotope. What is molecular weight of water? 18. What does it mean? 1 molecule of water is how many times heavier? 18 times heavier than 1/12th mass of C12 isotope. Or let us say atomic weight of oxygen is 16. What does it mean? 1 atom of oxygen is 16 times heavier than 1/12th mass of carbon 12 isotope. So the atomic weights and molecular weights we are using, they are not the real weights, they are comparative weights called relative atomic masses or relative molecular masses, comparative masses. Are you understanding or is it boring? Because I was told in the beginning of the lecture, you are missing some fundamentals, some key concepts. Without knowing atomic weight, molecular weight, we can't start chemistry. Correct? Okay, previously I am asking you a question. Why for expressing atomic weights or molecular weights, the earliest standards were hydrogen and 1/16th mass of O16. Now, why they were changed? Why 1/12th mass of carbon 12 is taken as standard? Why 1/12th mass of C12 is the most recent standard for expressing atomic weights or molecular weights? Why not the earlier standards like 1/16th mass of oxygen 16 or 1 unit of hydrogen? Why they were given up? Why we have switched over to this new standard? So write the answer. By taking 1/12th mass of C12 isotope, by taking 1/12th mass of carbon 12 isotope as standard, 1/12th mass of C12 isotope as a standard for expressing atomic weights or molecular weights. For expressing atomic weights or molecular weights, we can minimize the fractional values So what is the reason for switching to 1/12 mass of C12? To minimize then why chlorine has a fractional atomic weight 35.5? Write that question. Why Cl has chlorine? Why chlorine has a fractional atomic weight of 35.5? Yes, please. Anyone answer?
So it has two isotopes.
Yes, very good. The fractional atomic weights of elements is due to the presence of isotopes. So the answer is due to the presence of isotopes. So chlorine has two isotopes, 1735, chlorine 1737. This is 75%, this is 25%. In a particular percentage ratio, they are available. Means they are in 3:1 ratio. Now, average atomic mass of chlorine is equal to 75% of 35 mass plus 25% of 37 mass for total 100 units. This gives a value of 35.5. Or you can also say 3 units of 35 mass plus 1 unit of 37 mass for a total of 4 units. Whether you use this value or this value, you will get the same answer. So why some atoms are having fractional atomic weights? Due to the presence of isotopes in particular percentage ratio. Not only isotopes, in a particular percentage ratio. So whenever you want to find out the average atomic mass, you should not only know what are the individual atomic masses, but also in what percentage ratio they are present. Then only you can calculate the average atomic mass. Now here I will ask you a question on isotopes. Why not? Write a question, statement type question. Identify the number of correct statements. Identify the number of correct statements regarding isotopes. Identify the number of correct statements regarding isotopes. Number 1, they find same place in the periodic table. They find same place in the periodic table. Number 2, they differ in number of neutrons. They differ in the number of neutrons. Number 3, they have similar chemical properties. They have similar chemical properties. Number 4, they differ in certain physical properties. They differ in certain physical properties, like rate of diffusion. Like rate of diffusion. So how many of these are correct statements? What is the first statement? They find same place in the periodic table. Suppose in the periodic table, if I allocate one box for hydrogen with atomic number 1, that includes all the 3 isotopes of hydrogen. It contains H11, H12, H13. If I give hydrogen with atomic number 1 place, that includes the 3 isotopes of hydrogen. All have same atomic number. They differ in mass numbers. First one is called protium. Second one is called deuterium. The third one is called tritium. It is the lightest radioactive isotope. So isotopes find which place? Same place in the periodic table. You need not allocate each isotope a separate place. First statement is correct. What is second statement? They
have different number of neutrons.
neutrons number is different. Number of neutrons is equal to A minus Z. Mass number minus atomic number. The above number is called mass number. The subscript is called atomic number. This is called subscript. The written number above is called superscript, is called mass number. So mass number minus atomic number. For hydrogen, 1 minus 1, 0. For the second one, 2 minus 1, 1. Last one, 3 minus 1. So they differ in number of neutrons. Isotopes differ in the number of neutrons. Number of neutrons is equal to A minus Z. What is the third statement? Similar, since they have same atomic number, their electronic configuration is same. All the 3 isotopes of hydrogen have same atomic number. That's why same electronic configuration. Electronic configuration decides chemical properties. So all isotopes have similar chemical properties. Statement 3 also correct. What is statement 4? They differ in certain chemical properties like rate of diffusion. In rate of diffusion, lighter isotopes diffuse faster than heavier isotopes. Lighter isotopes diffuse faster than heavier isotopes. That is also correct statement. So all the 4 statements are correct. Actually, neat paper mainly contains statement type questions. They will give 4 statements and ask you to identify number of correct statements. So that means they want to cover the entire portion. When I give 4 statements, 4 areas I covered. Now, which isotopes diffuse faster? Lighter isotopes. They run fast, diffuse fast than heavier isotopes. Like that we can separate isotopes by taking the difference in the rates of diffusion. That is called atomolysis. What is the technique of atomolysis? What is atomolysis? Separation of isotopes by taking the difference in the rates of diffusion. What is atomolysis? It is nothing but separation of isotopes. Separation of isotopes by considering the difference in the rates of diffusion. Separation of isotopes by taking the difference in the rates of diffusion. So what is the principle? Lighter isotopes always creator, I am the destroyer. My dear Arjuna, you have nothing to do. Whether you do the war or not, these people cannot survive. Because I am the creator, I am the destroyer. So Born Oppenheimer is a German, settled in US. He learned this Bhagavad Gita and says, no, I have nothing to do. Even in future, if somebody use this bomb, I have nothing to do. Lord Krishna is doing all this. I am instrumental, you should not blame me. Exactly same thing happened when Japanese attacked the Pearl Harbor of America. Americans want to take revenge. That's why they dropped 2 nuclear devices. One in Hiroshima, the other is in Nagasaki. The temperatures produced by this nuclear explosion is more than 10,000 degrees centigrade. In hot summer, the hottest place on the planet Earth was the Death Valley in California. This year, it recorded some 56.5 degrees centigrade. The planet Earth, the highest temperature recorded every year is the same place, a desert place in California called Death Valley. This year many people visited that place to see the temperature. Digital thermometers are shown. it is showing 56.5 degrees centigrade, and the park authorities are warning the public, don't come, heat stroke will hit you. But people turnout is in large numbers. No, we want to feel that heat. As soon as they get down from the car, they are feeling that no, we are like in a furnace. No, we want to go back into the car. So after all, 56.5 degrees is an unbearable heat for the human body. If it is 10,000 degrees centigrade in nuclear explosion, is there any possibility of survival? No. So all the bicycles of Japanese school children were totally melted and twisted due to nuclear explosion. But some people claim that cockroaches, the arthropods, cockroaches belong to arthropoda, Periplaneta americana. Cockroaches can survive the nuclear explosion. How they survive, I don't know. But people say the only animal that can survive in a nuclear explosion is cockroach. Because even some reptiles like snakes can't survive if the earth heat is more. In the core of the earth, temperatures are more than 10,000 degrees centigrade. But earth heat won't reach the surface because the layers of earth are so thick. Whatever the inside heat, it won't reach the surface of the earth. If it reaches the surface of earth, can you walk on the earth? No. So all living organisms will vanish. The only country in which the earth layers are very thin and the earth heat comes to the surface, where snakes cannot survive. So which country is the snakeless country? Correct, he is correct. New Zealand. So New Zealand is the only country where snakes cannot survive. Because snakes are burrowing animals. They can't burrow into the earth layers because earth heat is more. Thus in New Zealand, they generate electricity in a different way called geothermal energy. They circulate water pipelines within the earth layers. Because of the earth heat, the water in the pipelines become very hot and convert into steam. Whenever you convert water into steam, that steam can be used to do a mechanical work and turn the turbines and generate electricity. One form of energy can be converted to other form. Because steam has hidden heat. What is that hidden heat we call? Latent heat. Steam has what? Hidden heat. What is that hidden heat we call? Latent heat. That's why there is a question in your NEET. The burns caused by steam are more severe in nature than the burns caused by hot water. Between hot water and steam, which is more dangerous to your skin? Steam. Why it is more dangerous? Because it has hidden heat. What is that hidden heat called? Latent heat. Okay. Coming back to, still we are in the mole concept. So we have defined atomic weight. Atomic weight is a mere number which indicates that how many times one atom is heavier than 1/12th mass of C12. Like how many times is heavier than that boy. So what is atomic weight? It is a number. What that number tells you? It tells you that how many times a given atom is heavier than 1/12th mass of C12 isotope. So what is molecular weight? It is also a number. What does it tells you? It tells how many times a molecule is heavier than 1 by 12th mass of C12. Formula weight, it is also a number, indicates that how many times one formula unit is heavier than 1 by 12th mass of C12 isotope. So all these three are same definition: atomic weight, molecular weight, formula weight. These three are similar. Atomic weight, it is a number. Molecular weight, it is a number. Formula weight, it is a number. What these numbers indicate? They indicate how many times an atom is heavier than 1 by 12th mass of carbon 12 isotope. So what is molecular weight? How many times a molecule is heavier than 1 by 12th mass of C12 isotope. What is formula weight? How many times? It is a number which indicates how many times one formula unit is heavier than 1 by 12th of C12 isotope. What is the molecular weight of hemoglobin? Would be doctors. Molecular weight of hemoglobin, I think it is 64,000, 64 or 67,000 like that. In adult human body, how many grams of iron is present? 5 grams. In our human body, how much iron is present? 5 grams only, just 5 grams. Like a teaspoon, 5 grams. In the 5 grams, 90% of the iron is in the form of hemoglobin, called ferroporphyrin complex. What is hemoglobin? Ferroporphyrin complex. It is a complex in which iron 2 plus is there. What is the coordination number of iron 2 plus in hemoglobin complex? I am talking coordination compounds. What is the coordination number of iron 2 plus in hemoglobin? The answer is 6. Coordination number is the number of coordinate covalent bonds that are linked to the central metal ion. In hemoglobin, the human hemoglobin, 4 bonds are formed by the pyrrole rings. 5-membered nitrogen containing rings are called pyrrole rings. Each nitrogen atom donates one lone pair. Like that, 4 pyrrole rings form how many coordinate covalent bonds? 4 coordinate covalent bonds. 5th coordinate covalent bond is formed by the protein chain. Hemoglobin contains 2 alpha chains, 2 beta chains. So a protein chain will link to the 5th coordination. 6th coordination is linked by oxygen molecule. When you are inhaling air, the O2 molecule this will donate a lone pair of electrons to the iron 2 plus of hemoglobin. If somebody donates electron pair, the other should have a vacant orbital. Then only a coordinate covalent bond, or it is also called dative bond. Coordinate covalent bond or dative bond. So iron 2 plus in hemoglobin complex form how many coordinate covalent bonds? 6. That's why the coordination number is called 6. Now the O2 the air which we inhale into our lungs, the lungs, every second you are inhaling oxygen. No sir, I want to take rest. For half an hour I don't inhale any air. Will we survive? No. Inhalation and exhalation is a continuous process. Respiration is a very key important role in our human body. So that's why nowadays in some places people are using gas geysers for hot water generation. Generally we use electrical geysers. In some areas people use gas, ordinary cooking gas. That will heat the water. But whenever gas burns, carbon monoxide is released into that bathroom. Usually bathrooms are very much closed. Carbon monoxide is colorless, odorless gas. It has no odor, smell. So if people want to take bath and enter into bathroom, close the door. Already they used the gas geyser for half an hour. Due to burning of gas, carbon monoxide, carbon dioxide, all gases are released. But the most dangerous gas is carbon monoxide, C triple bond O. This is the structure of carbon monoxide. Carbon is having a negative charge with a lone pair. Thus it is the best donor or strong donor of that lone pair. So whenever competition occurs between oxygen and carbon monoxide to give or donate lone pair to the iron 2 plus of hemoglobin, who is going to win the race? Carbon monoxide says, my dear oxygen, you are waste. I am bearing negative charge. I can push my electron pair strongly. And oxygen, it says, get out and occupy that place. And it is donated to iron 2 plus. Within minutes, our entire hemoglobin is filled with carbon monoxide. So death occurs instantaneously. The person will collapse and die. Even they don't know that they are dying also. So that much dangerous, the most poisonous gas, one of the most poisonous gases present on the earth is carbon monoxide. So generally it is liberated whenever you burn the fossil fuels. Fossil fuels, whatever the petrol, diesel, kerosene, the fuels we are using, they are called fossil fuels. Why they are called fossil fuels? Because the earth was ruled by long back huge dinosaurs, reptiles. In the Mesozoic era, you have studied in your biology, Huxley claimed that the golden age of reptiles is the Mesozoic era. Correct? So in Mesozoic era, the entire planet was ruled by big-bodied, huge, bulky-bodied dinosaurs. These dinosaurs suddenly disappeared. Where they went? They don't go anywhere because their body is so bulky, they can't travel to other planet. Mysteriously, all the dinosaurs were disappeared. The answer was a massive asteroid hit the planet. The planet Earth was collided by a big rock from the space. Then the Earth developed so many fissures, earthquakes followed by huge fissures. All the animals, huge forests were dumped into the earth, into the fissures. Later the fissures were closed due to the tectonic movement of the earth layers. When earth layers were closed, the trapped animals, the trapped forests, due to high heat content of the earth, they transformed into other substances. The vegetable matter, plants, huge trees, they are converted to coal. The animal bodies were melted and their fats disintegrated and form a thick black viscous liquid. That thick black viscous liquid, which we call petroleum or crude oil, is once the sacrifice of dinosaurs. Only the skeletons of dinosaurs we can retrieve. That's why the fuel is called fossil fuel. The fuels which nowadays we are using. Now I came to Calcutta to here. I changed 2 flights by using aviation turbine fuel, ATF. Flights uses separate fuel. It is also a type of kerosene actually. It also comes from fossil fuel. So whether we travel by air or a bike or a car, whatever it is, we are enjoying the benefits because of the dinosaurs only. These fossil fuels are going to exhaust in future. That's why scientists are looking for alternate energy resources like lithium-ion batteries. The inventor of lithium-ion batteries awarded Nobel Prize in Chemistry few years back, maybe 5-6 years back. 5-6 years back, Chemistry Nobel Prize gone to a scientist, American scientist, for developing lithium-ion battery. At that time, he was 99 years old. At the age of 99 years, he got the Nobel Prize in Chemistry. So the interviewer asked him, "How do you feel about the Nobel Prize?" He says, "Good, it is very splendid, but for my age, it makes no difference. But I feel very happy if my lithium-ion batteries are able to bring the people together. We are very happy. Because of lithium-ions only, we are using cell phones, we are using the camera, lithium-ion battery. Even all the electric cars, take Tesla or the Tata Nexon, any electric car, is also powered by lithium-ions only, lithium-ion batteries." Then the interviewer asked, "I came to know that you are still working at the age of 99. He says, "Yes, I am still working. I am in the lab every day. What shall I do? Shall I retire and wait for death? No, I don't want to do that." So why I am quoting this? At the age of 99 also is working. We should work. I think one more inspirational point for NEET aspirants. 4 years back, one retired bank manager from Odisha state, West Bengal, after that Odisha. He retired. After retirement also 5-6 years are gone. Maybe he is at the age of 65. He wanted to write the NEET examination at the age of 65, because he felt that while he was studying his 12th class, he could not get medical seat. There is no entrance exam at that time. Only the 11th, 12th marks based merit. He could not get a seat. So now there is an entrance exam. He wanted to prepare and write. He applied. Immediately the National Testing Agency, CBSE, they rejected his application. You are old man, about to die full. You want to write NEET exam by sitting with young people like you. So immediately he filed a complaint, writ petition in Supreme Court. They are denying my fundamental right to study. How these people can stop me? Though chronologically I am over-aged, no doubt, but I have the interest. I want to write the exam. Then Supreme Court initially gave a ruling, unless otherwise we give the final judgment, there is no age restriction for NEET. and he is allowed to appear for the exam. He prepared 1 year full and appeared the NEET exam and he qualified. Now he is in the 4th year of medicine now. In one of the Orissa's medical colleges, he studied. Later Supreme Court has given a final judgment also. In future there is no age restriction for NEET. Don't say that, no, okay sir, we will also write after 80 years, no. When you do it at a very young age, you can enjoy your medical profession for a long period, isn't it? For a 65-year-old person, after becoming doctor at 71, or after studying PG 3 more years, 75, what he can do? He can extend his service for 5 or 10 years more. And he can't be as vigorous as you. Correct? Because the cells, body mass, everything will be slowly disintegrating. I think every year 1 gram of body mass decreases as the people become older and older. So that is the thing. So when 65-year-old retired bank manager without any knowledge, he left his physics, chemistry, biology long back, no even smell of any subject. He, with a determination, he prepared 1 year full length like you and cracked the NEET. Why can't you? You can. This is one more inspirational point. Next question. How many gram atoms of each kind? How many gram atoms of each kind is present in 0.5 moles of glucose? How many gram atoms of each kind is present in 0.5 moles of C6H12O6. So 1 mole glucose is equal to Na molecules. Do you accept or not? 1 mole of any substance contain what? Avogadro number of molecules. So that is equal to 6.022 into 10 power 23 molecules. 0.5 moles contain how many molecules? Half the Avogadro number. Half into Na molecules. Half into 3.011 into 10 power 23 molecules. But the question asked is not to find the number of molecules. They asked about how many gram atoms of each type or each kind is present in half mole of glucose. 1 mole glucose or 1 molecule of glucose if I give 1 molecule of glucose, it contains how many carbon atoms? Very good. 6 carbon atoms. How many hydrogen atoms? 12 H atoms. 6 oxygen atoms. Instead of 1 molecule, if I use the word 1 mole glucose, if I use the word 1 mole of glucose, that same argument, 1 molecule contains how many atoms? 6 carbon atoms. 6 moles of carbon atoms. 12 moles of H atoms. 6 moles of oxygen atoms. 6 moles means 6 gram atoms. Mole is also called gram atom. Mole and gram atom are equal. The word mole and gram atom are synonymously you can use. 1 mole is equal to 1 gram atom. So 6 moles means how many atoms? 6 gram atoms. 12 moles means how many gram atoms? 12 gram atoms. Again here 6 gram atoms. If you take 1 mole, but here we have taken half mole. You can fill the last point. That is the question. 1 molecule contains 6, 12, 6. If I take the heading 1 molecule. If I take the heading 1 mole, 6 moles, 12 moles, 6 moles. Mole have one more synonymous word, gram atom. 6 moles means 6 gram atoms, 12 gram atoms, 6 gram atoms. But if I take half mole, yes, how many gram atoms of carbon? Half of this. So 3 gram atoms. Half of this, 6 gram atoms of H and 3 gram atoms oxygen. Actually, if you know the mole concept, the word mole, gram atomic weight, gram molecular weight, mole, gram atom, these words clearly You can solve any number of problems by using a simple technique called a mole triangle. 1 mole of CH4 methane. I write a triangle and mention inside 1 mole of CH4. At one corner, how many molecules I can write? Center is 1 mole methane. 1 mole contain how many atoms? How many molecules? Avogadro number of molecules. So at one corner I can write Na molecules, because 1 mole is always equal to Na molecules. Na is Avogadro's number. Or Avogadro's number of molecules mass is 1 mole. Avogadro's number of molecules mass is 1 mole. Or 1 mole always contain Avogadro number of molecules. 1 mole is also equal to its gram molecular weight. 1 mole is also equal to gram molecular weight. You know, methane is a gas. It is called a marsh gas. Since it is a gas, 1 mole of any gas at STP occupies 22.4 liters at standard temperature and pressure. This is called a gram molar volume. Gram molar volume. So what is this mole triangle? 3 corners. 3 corners. I used 3 different parameters in the triangle. 1 corner I wrote Avogadro's number. 1 corner I wrote its gram molecular weight. 1 corner it occupies 22.4 liters at ST. One more mole triangle simply I write 1 mole CO2, which is equal to how many molecules? Na molecules. CO2 is also a gas. That's why it occupies how much volume? 22,400 ml at STP, which is called a gram molar volume, GMV. It is equal to its molecular weight in grams, 44 grams. This is how you can create mole triangles. Once student is aware of a mole triangle, he can solve n number of problems. For example, all these are interrelated. They are not only interrelated with each other, they are also interrelated to the center. The 3 corners of the triangle, they are all interrelated. They are not only interrelated, they are also related to the center. What is that center? 1 mole. Now, if I ask you, what is the volume occupied by methane? What is the volume occupied by methane at STP, which contain 3.011 into 10 power 23 molecules? 3.011, not Avogadro number. I am taking half Avogadro number. Half Avogadro number of molecules of methane occupy how many liters? Avogadro number of molecules occupy 22.4 liters. If I take half the Avogadro number, 11.2 liters, or 5.6 liters of methane at STP weigh how many grams? 4 grams, correct. Because 22.4 liters is weighing how much? 16 grams. 1/4 of 22.4 is 5.6. So it weighs how much? 1/4 of 16, which is 4 grams. Find the weight of single molecule of methane. Find the weight of single molecule of CH4. See this interrelation. Avogadro number of molecules are weighing how much? Avogadro number of molecules are weighing 16 grams. One molecule weigh how much? So this is the relation. 6.022 into 10 power 23 molecules of CH4 weighs 16 grams. One molecule weighs how much? 16 by Avogadro number. So roughly if we take 6, it is how many times? 12. 2 6 are 12, 4 is remaining 40, 6 6ers, some 2.66 into 10 power minus 23 grams. That is weight of single molecule. So we can derive a formula here. Weight of single molecule is equal to gram molecular weight by Avogadro number. Now I am constructing one more mole triangle. 1 mole of helium. Write all the 3 corners first. What is the top corner? What I write? Avogadro number of what? Helium contains molecules or atoms? Atoms, because it is inert gas. One corner, its atomic weight is 4. In grams, 4 grams, which is called a gram atomic weight. Helium is also a gas. How much it occupies? 22.4 liters at STP. Like that, students should be able to construct mole triangles. In mole triangles, all the 3 corners are interrelated. They are also related to the central part, that is 1 mole. Suppose if I ask you, now write one problem. What is the weight of single atom of helium? What is the weight of single atom of helium? Means I am seeking this relation. Avogadro number of atoms weight is 4 grams. 1 atom weighs how much? 4 by Avogadro number. So this is the relation. So write the same. Avogadro number of atoms of, not molecule, atoms of helium weighs how many grams? 4 grams. 1 atom weighs how much? 1 atom weighs how much? 4 by Avogadro number. 6 into 10 power 20. 4 by 6, 2 by 3. 2 by 3 is 0.6. Minus 23 grams. Or 6 into 10 power minus 24 grams. So what is the formula for weight of single atom? What is the formula? So weight of single atom is equal to gram atomic weight by Avogadro's number. Here gram atomic weight is 4. Avogadro number is this. Like this you can calculate the weights of single atoms of any substance or weights of single molecules. Which is true? Write a question. Which is true regarding helium? Number 1. It is used in the breathing apparatus. It is used in the breathing apparatus or breathing equipment of deep sea divers. In the breathing apparatus or breathing equipment of deep sea, S-E-A-C, divers, D-I-V-E-R-S. Number 2, its atomic weight is equal to 4. Number 3, a single atom of helium weighs 4 AMU. A single atom of helium weighs 4 AMU, atomic mass units. Number 4, A single atom of helium weighs 4 grams. How many of these are correct? So these are all just now created questions. Sometimes our mind thoughts will coincide with the paper setter. Same question may come in the exam. It is just mere coincidence, not an extraordinary power. Sometimes whatever we talk, we discuss in the class, same questions come in the exam. Students surprised, sir, whatever you discussed came. Not a great thing. Whatever there in the syllabus we are discussing, obviously they have to come. Okay? So how many of these statements are correct? What is the first statement? I think some of you went deep into the sea, scuba diving, or sometimes the marine biologists, they jump into the sea to see the flora and fauna at the seabed. So they go deep into the sea. So when they go, they should wear an oxygen cylinder to support their respiration. But when you are going deeper and deeper into the sea levels, pressure increases. When pressure increases, the solubility of gases in liquids increase. Which law? Henry's law. Solubility of a gas in a liquid is directly proportional to its partial pressure. That is Henry's law. So when the diver going deeper and deeper into the sea, more and more oxygen will be dissolved in his blood. The liquid is blood here. He is inhaling oxygen to support his breathing. So at deeper levels, higher depths, pressures are more. When pressure is more, the gas is more soluble in the blood. So the oxygen will be soluble in the blood. When the diver comes back to the normal sea level, whatever the gas dissolved under pressure, it will again come into gaseous state. The entire blood vessels are filled with O2 bubbles. Whenever the gas vessel, arteries and veins, they are filled with gas bubbles, there is a discontinuity in the flow of blood. Whether heart receives the blood from the veins or heart pumps the blood by arteries. In both cases, heart muscle confuses. It has no proper continuous circulation of blood, nor it can pump the blood in a proper circulatory manner. Then the heart muscle suffers huge muscular pain. It was discovered by a doctor called Dr. Kaizen, K-A-I-Z-E-N. It is called a Kaizen's sickness, popularly called as bends. It is in our syllabus. Neat syllabus point only I am talking. Kaizen's sickness or bends is a particular body condition where the diver feels extreme muscular pains, including heart muscle. Then sometimes it is fatal also. That's why to avoid this more solubility of oxygen in the blood at a deeper levels under pressure, the breathing apparatus or equipment contain a mixture of helium and oxygen. So the deep sea divers breathing apparatus contain a mixture of helium plus O2. This can also be asked as a question. The deep sea divers breathing equipment contain option 1 pure oxygen, option 2 pure oxygen plus pure nitrogen. Like that different combinations also they can give. So your answer is It is a mixture of oxygen plus helium. Why helium prevents solubility of oxygen gas in blood? You know, two gases are close to ideal nature, hydrogen and helium. Their intermolecular forces are very negligible. Between hydrogen, helium, intermolecular forces are negligible. Whenever there are no intermolecular forces, the gas is said to be an ideal gas. Since hydrogen and helium are very close to ideal nature, helium is used to prevent the solubility of oxygen in the blood when the diver goes deeper levels of the sea. So first option is correct. What is second option?
Its atomic weight is 4.
Its atomic weight is 4, correct. Atomic weight of helium is 4. Means one atom of helium is 4 times heavier than 1/12th mass of C12. Actually 1/12th mass of C12 is called 1 AMU. Moles. You can calculate molarities and all the problems related to the concentration unit molarity. So molarity is a concentration unit to express the concentration of a given solution. So what is how we define molarity? The number of gram moles of solute present in 1 liter of a solution is called molarity. What is molarity? Number of gram moles or moles of a solute present in 1 liter of a solution. And its units are moles per liter. What are the units of molarity? Moles per liter. Is molarity temperature dependent? The answer is yes. With increase in temperature, as the volume increases, the volume term is in the denominator. So when temperature increases, molarity decreases. Write a question. Find the molarity of of pure water find the molarity of pure water at 4 degrees centigrade. At 4 degrees centigrade. Because at 4 degrees centigrade, density of water is 1 gram per cc. Water has maximum density at 4 degrees centigrade, which is almost equal to 1 gram per cc, cubic centimeter. Molarity capital M is equal to number of gram moles of the solute present in 1 liter Simply you can say molarity is equal to N by V. V in liters. What is N? Given weight by gram molecular weight. So in the place given weight is W, let us say it is W by gram molecular weight. So here I can substitute M is equal to, in the place of N, W by GMW into 1 by V liters. From this you can also derive, you can also say N is equal to M into V liters. From this you can also write M is equal to W by gram molecular weight into 1000 by volume in ml. Like this you can write many different formulae. So number of moles of water at 4 degrees centigrade is equal to so actually here 1000 ml of water that is 1 liter of water at 4 degrees centigrade is equal to 1000 grams. Do you accept or not? Because already we have given density is equal to how much? 1 gram per cc or ml. 1 cc weighs 1 gram. 1000 cc weighs 1000 grams. So when I want to find the molarity of water, I have to take 1 liter of water. Which is weighing how much? 1000 grams. Once you know weight, you can find out the number of moles. Given weight by gram molecular weight. Given weight is 1000 grams by gram molecular weight 18. It is 55.5. This is molarity of water, pure water at 4 degrees centigrade. Again I repeat, please look at. So I asked you to find molarity of water. Water is not a solution, solvent only. Actually you can also question me. Molarity is a term for solutions. Here we have taken pure solvent and asking the molarity. It's a very interesting question. How the term applies to pure water? Yes, I want to find the number of moles in pure water for 1 liter. Of course, 1 liter water is equal to nothing but 1000 grams. So 1000 grams divided by the gram molecular weight of water, that is 18. So 1000 by 18, I got 55.5 moles. That is present in 1 liter water only. So 1 liter water, how many moles are present? That is molarity. What is molarity? Number of moles present in a particular volume, V in liters. So how many moles we got now? 55.5 moles. In how much water? Means 1 liter water. That is molarity. So here we equated the volume to weight because density is 1 gram per cc. So 1 liter water weighs 1000 grams. Once we know the weight of water, number of moles you can calculate. It is always weight by molecular weight. Write another problem. 10.6 grams of 10.6 grams of sodium carbonate Na2CO3 is present in 100 ml of a solution. .6 grams of Na2CO3 is present in 100 ml of a solution. Find its molarity. Find its molarity. Sodium carbonate molecular weight is 106. What is Na2CO3 molecular weight? Na2CO3 2 into 23 plus 12 plus 3 into 16. You will get 106. So this formula we can use. Weight is 10.6 by gram molecular weight 106 into 1000 by V in ml, 100 ml. This formula I am using. So to remove this decimal I put one more 10. So this cancels. Now this 1000 cancels. So the answer is 1 molar. Final answer, molarity is equal to 1 m. 10.6 by 106 into 1000 by 100. If you simplify, you get 1 molar or 1 mole per liter. 1 capital M you can use. Now in one of the formulae that are present on the board, you can see number of moles. N is equal to M into V liters. This one. N is equal to M into V in liters. Using this formula, we can use the word called dilution law. Number of moles before dilution is identically equal to number of moles after dilution. Number of moles after dilution. Because what is the formula? N is equal to M into V. Suppose you have, please listen, you have 1 mole in 1 liter. 1 mole in, now we added 10 liters to that. Still it is diluted, but mole is 1 mole only. So before dilution, 1 mole in 1 liter. After dilution, 1 mole in 10 or 10 plus 1, total 11 liters, whatever it is. But moles are same. So number of moles before dilution is equal to number of moles after dilution. From this we can say M1 V1 is equal to M2 V2. M1 V1 is equal to M2 V2. And V2 minus V1 is equal to volume of water added for dilution. What is V2 minus V1? Volume of water to be added for dilution. Based on this, please write a problem. How much water is added? How much water is added to convert? How much water is added to convert? Visibility is very poor, no? Back benches, visibility is very less. Actually, this is an interactive board, not a regular whiteboard. Even the other board we can use if it is properly cleaned.
We have chalk and then put it on the board.
We have.
That board has 2 sides, one with a marker and one with chalk.
The same board which we are using. No, side one. Okay. Achha, tomorrow we'll switch it to the chart model. There the visibility will be more. Now why are you telling in the last? In the beginning itself, you might have given the suggestion. Okay. How much water is to be added to convert? 0.5 molar. 0.5 molar. 200 ml. 0.5 molar, 200 ml. H2SO4 solution. H2SO4 solution into decimolar solution. How much water to be added to convert 0.5 molar means capital M, 200 ml H2SO4 sulfuric acid, H2SO4 solution into decimolar solution. Into decimolar. Decimolar, DECI. Tomorrow we will convert this into that green side, and with a white chalk, green background, visibility will be more. That we will do. Okay, now this problem. So this we have to find out. So M1 V1 is equal to M2 V2. M1 V1 before dilution, M2 V2 after dilution. Initially we have taken 0.5 molar of volume 200 ml into decimolar, 0.1 molar. 0.1 is called decimolar into V2. First you find out V2. How much you got? V2 is how much? V2 is 0.5 into 200 by 0.1. So this is 1000 ml. So volume of water to be added is equal to V2 minus V1. 1000 minus V1 how much? 200. So the answer is 800 ml. This is the answer. Next problem. Any doubt? doubt in this? Because molarity into volume gives number of moles. So number of moles before dilution is equal to number of moles after dilution. So when you multiply molarity term with volume term, what you are getting? Number of moles. Number of moles won't change. Before dilution or after dilution, number of moles will remain same. But only the quantity may change and it may become more and more diluted. Here I am going to create a problem based on weight fraction into degree of hardness. So write the point. 12 grams of MgSO4, 12 grams of magnesium sulfate, MgSO4, is present in 1 kg of hard water. Full stop. Its degree of hardness is Look at this. So weight fraction weight of solute capital W by weight of solution small w. Suppose if you want percentage W by small w is equal to W by small w into 100. This is called percentage W by W. If weight fraction is multiplied by (10⁶), then you will get parts per million. Generally, degree of hardness is expressed in parts per million. Degree of hardness is always expressed in terms of calcium carbonate, CaCO3. 1 mole of CaCO3 is identically equal to 1 mole of MgSO4. 1 mole of CaCO3 is equal to how much? Its gram molecular weight. 1 mole of CaCO3 is 40 plus 12 plus 48. So 100 grams equal to 1 mole of MgSO4. 24 plus 32 plus 64. That is equal to 120 grams.